Hello everyone, welcome to my channel. Today we will derive equation of a plane in normal form, so which is going to be asked for 5 marks. So we'll see how to solve this question. So here is a consider a 3D plane here with a normal given. See, any line perpendicular to the given plane is called normal, right? So let us consider there is a one normal passing through the origin and perpendicular to the plane, say it is ON. So ON is my normal. ON is a normal drawn to the plane. The normal drawn to the plane, and let us consider D is a distance of a plane from the origin. D is the distance of a plane from the origin. And then one more concept, let us consider n cap. N cap is the unit normal vector in the direction of my normal ON vector perpendicular to the plane. N cap is the unit normal vector perpendicular to the plane in the direction of my normal vector ON. Therefore, again you consider one more arbitrary point P on the plane with the coordinates x, y, z, and if I join this OP, I will get a one position vector R. Okay, so here is my OP is the position vector of a point P. Position vector of a point P. So I will denote it by what? R, which is given by xi cap plus y j cap plus z k cap. Okay, and then I will join this P point and N point. So join NP. Okay, so this NP is perpendicular to ON. You can observe here my NP vector is perpendicular to ON vector, right? And one more thing, here ON vector is simply given by n cap into D, where n cap is a unit normal vector and D is the distance of a plane from the origin. So we will get ON vector as n cap into D as well as OP vector as R vector, which is equal to xi cap plus y j cap plus z k cap. Okay, so here in the derivation we have to determine the equation of a plane both in vector form and normal form. For that, look at the concept here. Since here my NP vector is perpendicular to ON, so if I join P point and N point, I will get a one vector, that is NP vector here, which is absolutely perpendicular to the plane, given normal vector ON. Okay, we know that if the two vectors are perpendicular, let us suppose take out A is one vector, B is one vector. If they are perpendicular to each other, then their dot product is 0, right? So in the same concept, here NP is perpendicular to ON. This implies their dot product is 0. Nothing but NP dot ON equal to 0 agutte. Okay na? Then we can again write NP vector as simply with reference of origin OP minus ON. ON vector dot ON vector, that is equal to 0. From figure we can observe OP is my R vector. So I will substitute here OP is my R vector minus ON is already written n cap into D. ON is n cap into D dot again ON is n cap into D, that is equal to 0. We know that D is the distance of a plane from the origin. So this D will goes to RHS side, it becomes 0 here. So finally I will get r vector minus n cap d dot n cap equal to 0, where this d goes RHS side becomes divided by d, so 0 by d is what? 0. Next you take a next step, so r dot n cap, split it, so r dot n cap minus d in d dot, see I will make exchange here, d dot dn cap, you can write dn cap dot n cap, dn cap dot n cap equal to 0. Again r dot n cap minus, we know that dot product of a unit vector I dot I, j dot j, all are equal to what? 1. So n cap dot n cap is equal to 1 here, so I will get d into 1, that is equal to 0, because we know that n cap, the dot product of unit vector is always equal to 1. So finally we will get here r dot n cap minus d equal to 0, otherwise r dot n cap is equal to minus d, I will shift here, it becomes plus d. So this is my equation of a plane in normal form, that is vector equation. So vector equation of a plane in normal form, vector equation of a plane in normal form. For board point of view, examination point of view, this question will be asked for 5 marks. So now we have derived only vector equation of a plane in normal form, still we have to go for Cartesian form. We'll see how to derive the Cartesian equation of a plane here. Before that, go through once again. Here my ON is the line passing through the origin and perpendicular to the plane, therefore ON is treated as my normal which is drawn to the plane, and d is the distance of a plane from the origin. So plane origin in the ಎಷ್ಟು distance ನಲ್ಲಿದೆ, that is nothing but your d, okay na. And n cap is the unit normal vector perpendicular to the plane which is in the direction of ON. So ON vector directionally n cap irutte, that is a unit vector n cap. And we take an arbitrary point P on the plane with the coordinates x, y, z. Therefore we can write OP as my position vector r. So I have taken here OP as my position vector of a point P, which is denoted by r vector. We know that ON is perpendicular to the PN, otherwise NP, because NP is a vector on the plane and ON is perpendicular to the plane, so both are what? Perpendicular here. So if the two vectors are perpendicular, then their dot product is what? Absolutely equal to 0, because we have learned this concept in vector algebra. And we can write NP by using triangle law. You can find your NP as simply nothing but OP minus ON. See, remember, if you write AB vector here, you can write it as OB minus OA with the tricks method, right? So usually you can write NP as OP minus ON. Simply you can write here. Okay. So now we'll go for the next step. So update the value of OP vector and ON vector. OP is my R vector, ON is n cap D, or you simply can write dn cap, no problem. And dot ON. So put the value of ON, then rest of the thing you will get the equation of a plane in normal form, that is vector equation is given by r dot n cap is equal to d. You must know that what is r, what is n cap, and what is your d, right? In the further steps we'll go for Cartesian equation of the plane. Okay, look at now. We already know that this point P is with the coordinates x comma y comma z, right? So if I join this origin O and point P, so I will get my position vector r, right? So OP is my position vector r, which is given by x I cap plus y j cap plus z k cap. Again here ON, here my ON is the normal vector. ON is the normal vector which is given by d n cap, nothing but d is the distance of a plane from the origin, and n cap is the unit vector in the direction of my normal, right? So we got ON as dn cap. So we know that vector equation of a plane as r dot n cap is equal to d, right? Here n cap is the unit vector in the direction of my normal. Let us consider L, M, N are the direction cosines of my normal, then n cap can be written as Li plus Mj plus n k cap. So this point you should note it. N cap can be written as Li plus Mj plus nk. Therefore, in the further step, here my r vector I can simply write xi cap plus yj cap plus z k cap dot Li cap plus mj cap plus n k cap, that is equal to d. We know that how to find the dot product. So here corresponding I component, j component and k component we can do. So L into x we get Lx plus m into y we get my plus n into z we get nz, that is equal to d, right? So Lx plus my plus nz is equal to d. This indicates the Cartesian equation of a plane in normal form. Cartesian equation of a plane in normal form, where your L, M, N indicates the direction cosines of a normal, where L, M, N are the direction cosines of my normal vector ON. So this is how you have to derive the equation of a plane in normal form, both in vector equation and Cartesian equation. Please do remember these things. Okay. So finally we got the vector equation of a plane in a normal form is given by r dot n cap is equal to d, where n cap is equal to Li plus mj plus n k cap, and d is the distance of a plane from the origin, and Cartesian equation of a plane in normal form is given by Lx plus my plus nz is equal to d, where L, M and n are the direction cosines of my normal vector ON. So hope all of you got the point, and the next equation of a plane in passing through the point will do the derivation in the next video.